Welcome back to our MSIX series. Today we will explore the Package Support Framework, or PSF, which is a crucial tool for running Win32 and WPF applications inside an MSIX container. Now, I already shown some examples where the PSF must be used, and I know we talked about it many times throughout this series, but we need to understand that PSF helps resolve compatibility issues when migrating legacy applications, making the transition to MSIX smoother and more efficient. Now, the PSF is an open source framework which is created by Microsoft, and this can be found on their GitHub page. Their scope was to address issues that arise when repackaging applications into MSIX. By using runtime fixups, PSF modifies the application behavior without requiring changes to the original application source code. This is especially useful for legacy applications where the source code is either limited or unavailable, or for the IT professionals who work in the software repackaging area and for sure they don't have access or have very limited knowledge on how to modify the application. As a side note, the PSF utilizes the detours technology, which again, it's an open source framework for API redirection and hooking. This helps manage and redirect API calls to ensure that the application functions correctly within the MSIX container. So, inside the package support framework, to use PSF in your MSIX package, you will need several key resources. I'm just going to name them here, and then we will have a look over a package to understand them. First of all is the PsfLauncher, which is necessary to use the PSF in the first place. Then you have your PSF runtimes. This should be included based on your application's architecture. Your config.json file, which specifies and configures the fixups used by your application. And of course the fixup DLLs, which are predefined or custom fixups that address specific issues. Now, commercial packaging tools like Advanced Installer offer direct integration with PSF, simplifying the inclusion of these resources. If you are using Microsoft MSIX packaging tool, this has been updated in the recent releases to aid in the PSF manipulation via graphical user interface. Or you can use the free third-party tool PsfTooling by Team Mangan, which can assist with injecting and configuring PSF components. To use the PsfLauncher, you need to replace the traditional shortcut created by the application installer with a new one pointing to the PsfLauncher executable. The configuration file, the config.json, informs the PsfLauncher about the real target application and how to start it. So, before we go into this, let me show you how easy it is in nowadays to add a certain fixup. So by looking at the MSIX packaging tool, I want to edit a package that I already have. For example, let's go on my desktop and I have here this package. I can open it, and now you have your PSF fixups. You select your application where you want to apply your fixup, and for example, as you know, VLC also has some command line arguments, right? For example, the VLC media player skin, if you go into properties, you see that your target has this specific property or this command line argument. So let's copy this and put it here. Next, we click save. We don't increment the package, and you can save it however you want. We can leave it with 2. This would save our changes and create a new package on the desktop. Now, let's have a look a little bit over this MSIX, which has been modified. So if we open it up with 7-zip, actually, for me to better explain this to you, let me open up the original file as well, the original MSIX. So let's see the differences. So on the top is the original MSIX file or MSIX package for VLC Media Player, and on the bottom is the modified version with the PSF included. So as you can see, there are some differences. As mentioned, the VFS folder is the primary folder where all the files are stored, right? So this hasn't changed, right? We still have the app data, the program files, whatever, right? This hasn't been changed a bit. You have the same exact folder structure. What has been changed a little bit is what you see here under the root of your MSIX package. So what you have here is your PsfLauncher, your PSF runtimes, your configuration.json, and your fixup DLLs. So as mentioned, if you need to add, for example, in this case, a command line argument, we need to replace the traditional shortcut, because the PsfLauncher starts the target executable, which in our case is VLC Media Player, and performs DLL injection for the necessary fixups. This setup ensures that the application runs smoothly within the MSIX container by addressing any compatibility issues dynamically. The startup sequence involves the PsfLauncher starting the real target executable and then injecting the required fixups, such as, for example, I don't know, file redirection fixup.dll into the process. Now, if we extract the configuration.json file and have a look over it, and if we open it with Notepad, we can see how it actually looks. So, what are we doing here? Well, when the PsfLauncher is executed, it reads into this configuration.json file and says, okay, I have an application ID. This is the shortcut, let's say, which, by the way, you can have multiple shortcuts. In this case, when the ID with VLC is opened, please run this executable. And in this case, because I only want to have a command line argument, please also include these arguments when you launch that specific executable. Then the PsfLauncher does its things, injects the runtimes, and opens up your VLC Media Player as skinned. Of course, we can also have a look over the Apex manifest. And if we have a look over it here, you know, I mentioned that in the Apex manifest, your application ID will have your executable. Previously, this was vlc.exe, but now our executable is the PsfLauncher. Because this is a 64-bit MSIX, we are going to use the PsfLauncher 64. Now, identifying the required fixups for your application can be challenging. Tools like PsfTraceUpFix, Process Monitor, and Process Explorer help by tracing the API calls and examining application behavior to pinpoint the compatibility issues. PsfTraceFixup logs API calls that might need redirection or modification, providing insights into where the fixups are needed. Process Monitor captures files and registry activities, offering a detailed view of the interaction between the application and the system. And Process Explorer, although not a tracing tool, helps understand command line arguments, process bitness, loaded modules, kernel objects, which can be critical for identifying issues. In general, there are some common types of issues, and the fixups used to address them are, for example, this one with the shortcuts, where we have issues with the command line arguments and working directory. We use the PsfLauncher like I just showed you in this example. We also have scripts, because you cannot run custom actions like we did with MSIs back in the days, but what Microsoft offered us is the ability to pre-launch or post-execute scripts. And when I'm saying scripts, I'm saying only PowerShell scripts. So for this, again, we need to use the PsfLauncher. In case you have any missing files or visibility issues in the VFS folders, we need to use the file redirection fixup. Actually, let me open up this here. And if we open the package again, let's see some standard ones, right? Next, we have the writing to package files, which allows applications to write inside your installation directory. And here we should use a file redirect fixup, right? In case your DLL is not found, we must ensure that the applications will find them in the package, and in that case we have the dynamic library fixup. In case we need to modify the registry access permissions to write to the registry, we can use the registry legacy fixup. And in case we have any missing environment variables and we want to manage the environment variables, we just use the environment variable fixup. These predefined fixups help ensure that your application runs smoothly within the MSIX container by addressing common compatibility issues. If you want to add additional fixups, then you will need to actually build your fixups, right? You need to do your own fixups in the DLL and add it manually inside the MSIX package. In general, Advanced Installer and PsfTooling streamline the process of applying PSF to your MSIX package. Also, if we open up this package with Advanced Installer, again, we have here all the things you can add: file redirections folder, public file, DLL paths, PowerShell scripts, registry key access, registry removal, or custom define. But Advanced Installer also offers is a built-in debugger, which traces your app and identifies necessary fixups. I already showed you this in the Advanced Installer Express edition. And you can also configure your tracing options, your trace levels, your break-on, and so forth and so on. Thank you for watching. We hope this guide to the PacKit support framework helps you manage and deploy your MSIX packages more efficiently. Be sure to subscribe and hit the bell icon for more videos on MSIX and other packaging tools. If you have any questions or need for further assistance, don't hesitate to get in touch with us.